delegates, respected sponsors, and who all are here, all engineers and architects. It's only going to be a 1 hour's journey along with you, steel all the way. Okay. And I'm going to actually take you through what steel is doing today and how do we go about the various aspects of the steel, you know. So these are few points which I'm going to touch quickly in this workshop. Increase in usage of steel buildings, PEB boon to the industrial construction. I wrote an article, I think, way back in 1980s, which was titled as "Ye PEB, PEB Kya Hai Bhai?" And it became a nationally popular article because I had really brought up certain things and put into that. I was educated in Zurich, Switzerland earlier, 1976 to 85. So that gave me actually a know-how of PEB much earlier than it touched India. So that is something which we will discuss today. Points to be considered for PEB design. Now, if we are going for a PEB design, what are the various points that we should consider? So that is another thing. And then we have floating PEB inquiries. There may be some consultants. Sorry, sir. There may be some consultants who will be inviting PEB inquiries, and they really do not know how do we invite those inquiries. And I know the smart PEB guys today, they try to override the clients as well as the consultants. So because they think that they are much smarter than the consultants themselves. So I'm going to discuss those points and process from PEB agency selections to handing over of the project. Now, this is also very important for those who are executing PEB projects, particularly PEB companies. How do we want to go with the time frame and the quality frame and the transportation and various factors involved within that. Option of sheeting, glazing, canopies, roof lights, and ventilators. Now, these are some of the additions that are happening today. We have different kinds of ventilators than what we had earlier to start with. So we have a ridge ventilator, we have a roof monitor, and we have various other things. We have turbo ventilators, we have standing SIM, and then how to fit in the turbo ventilator to the standing SIM. So various issues, where you actually touch upon certain new aspects. So that is something which I will try to cover. Now there is a new concept coming out, it's called solar roof. So we don't have to actually put a solar panel on the top of the roofing sheet. The solar panel itself can become a roofing sheet. So I'll just elaborate on that. And then we have multi-storied buildings, and of course, the latest one that we have been using widely, and it will, I suppose, will be used widely later as we progress, that is called light gauge form steel. So that is LGFS. So we'll just touch all these quickly. क्या हो गया भाई? Okay. So again, we have been discussing this on to the presentation that we had yesterday as well. But these are few points, how and why there is an increase of steel in buildings. What are those points? So point number one, of course, due to their ability to withstand weather conditions, long-term durability, incredible insulation. Because when we talk of concrete building, I think we are talking about a lifespan of 40 to 50 and nothing more than that. And when we talk of steel building, the bridges more than 100 years are still there. And that is what you can compare, the lifespan. The second one is the design freedom that the steel gives you. So that is something really interesting. We have long span structures is the demand of the industry today. And we have designed something like 80 meters by 80 meters without any columns. And the client were so pleased that they could place their machines the way they want. So that is something, it gives you a lot of design freedom. Those who are architects, I think they can play with their forms and their features and whatnot. So open areas, open structures that are prone to be affected by elements such as humidity, heat, and hazardous gases, etc. They call for durable steel structures. Wind and snow conditions and seismic activity. These are the things that are there. Now, advantages of the pre-engineered. So let us shift to the main topic, which is a PEB or the pre-engineered buildings. Reduce construction time, obviously. So what you spend, actually the manufacturing time, I think Interage people will agree not more than a week. So whatever the manufacturing is, of course, the design may take a little more time. So lower costs, ease of expansion, assured quality, less maintenance, energy efficient roof and wall systems, architectural versatility, and those are very important. Architectural versatility, and then increased accountability. This is just a comparison between conventional steel buildings and the pre-engineered building. You know, because I won't just say that we go for a pre-engineered because it is so and so and so and so. It is actually a point-wise comparison where we are talking about structural weight of primary, and just note the highlighted features wherein we are saving 30%. People say that PEB buildings are costlier than the conventional. So I'm trying to prove that it is not the fact. You will have the primary which is 30% lighter. The hot rolled will be heavier. Structural weight secondary, again, read the red lines. Design, quick and efficient, specialized computer analysis, and of course design shop detail sketches. Because I have seen in the traditional or conventional steel structures, people used to draw sketches on the walls. You know, thoda ye I section aisa karo, bracket udhar le lo, 50-50 by 6 le lo, 100-100, whatever. So it was, I don't know, was it a real engineering? It was not so. So in PEB, we actually get on to these three factors very effectively. Then again, design consultants in-house design and drafting time is considerably reduced. So as far as the detailing and things like that are concerned, because it is all depending on very good softwares that have come for PEBs. So they are reduced, and more complicated design requiring in case of conventional buildings. Now what is the delivery time which I was telling, you know? You will agree with me, it is 6 to 8 weeks I have said. Okay, so anything that you give me, 6 to 8 weeks delivery time, and you compare that. You know, yesterday we were discussing about a multi-storied building in Hyderabad. Basically, why we went for steel is saving in time. Spending about 300 crores of rupees on a project, and the project gets completed in 3 years span. If you go for an RCC building and you go for a PEB building, it was completed in 10.5 months. You can imagine the kind of interest saved on an investment of 300 crores. Now, that is something which we are talking about this. Foundations again, simple design. There it is, heavy foundations. Erection simplicity, erection cost in time. And again, I am elaborating on erection cost in time. So the basic thing is the erection part. You know, because many times people discuss with me that in case of conventional, the erection is not really the case because most of the time things are done on site. Therefore, the erection part is, you know, the way it happens. It is not graft, it is not planned. But here we can do that. Seismic resistance, low weight, flexible frames. They are rigid ones. Overall price per square meter may be 30% lower again. And architecture is outstanding architectural design can be achieved at a very low cost. Similarly, sourcing and coordination, as you all know, it is going to be one single source and not too many agencies, you know, one guy for erection, one guy for painting, one guy for fabrication. All those things are avoided. It is only one shop which does it. Cost of change orders, they are easily accommodated, and building accessories, n number of them, and I think we are still developing further as far as the PB people are concerned in terms of accessories to be required for designing the building much before. We have future expansion. Now this is something really very interesting. The future expansions, of course, is always a boon to any steel building. I would not say conventional versus PEB. Easily possible. Now, in case of PEB, what we do is we anticipate a master plan and then phase out and then provide for the expansion to come up. Okay, so that's very easily possible. And then responsibility, single source again, because the supply is a single guy. Performance, all components have been specified and designed, and experience with similar buildings is also there. Whereas conventional, each building design looks almost unique. I compare this with, your brands like McDonald's and Kentucky and whatnot, KFC. They're all same anywhere, any part of the world. Does that happen with the conventional building? No. It all depends on the kind of a fabricator. It all depends on the kind of the agency involved. But with the PEB, I think we can standardize all that, at least company-wise. And not only company-wise, but all companies come together, use the same software, and probably go for the similar kind of detailing. I think it can be modular and it can be very unique. You can do it any part of the world, with that. So global experience, the company has acquired vast experience in the performance of PEBs in different climatic conditions. So that was my article, and I just actually ran through that. We are just trying to come out showing you certain projects, and then also have some highlighting elements. So the fact is that PEB technology reached our doorsteps pretty late. Let me tell you, as I told you, that I was in Switzerland, and we were associated with a Swiss company where I got my basic trainings. So that was way back in 1976 to almost 82, 83. So we were doing PEB those days, whereas we landed, I think, around 85, 89. So we were so late to really come out with this kind of technology. Availability of structural steel was a major issue, and the cost, of course, attached to it. So they were the main thing. Urgency of raising the structures in absolute minimal time, ensuring quality. Now, this requirement also in India, I think, came off late. Otherwise, we were always saying, chalta hai, ho jayega, and things like that. So we are not really worried about time. Now, today's situation is most of the clients will drop in, and they say that we wanted yesterday, this particular project, we have reached you late. We want to go into production in the next couple of months. And they don't worry about what area they want to build. So they'll just give us all those challenges of time. And of course, they will never compromise on quality at the same time when we are working on time. So minimal time ensuring quality is something which actually forced us to take up the pre-engineered buildings thing. Growth center of emerging economy is what has forced us, raising complex industrial and allied structures. Now, this is one project which we have done in Supa MIDC. It's a 3.5 lakh square feet. As you can see, long span structure. And we completed it in a short span of 6 months. 6 months. So including, as I always say, pencil to production. You pick up a pencil with an idea, develop the idea from concept to the detailing and things like that, get into the manufacture, get into the erection, and complete the whole process. So the RCC design is left up to plinth. I'll come to that procedure as well. People say it is not possible to design some beautiful or handsome buildings. We have done it. It's a 50-meter span building for a Japanese company called Mikipuli in Mumbai. And you can see how beautiful it is. So from internally, externally, and the Japanese guy really loved it. The canopy that comes out for 7.5 meter steel frame with glass top. Now the codes and advantages, 15% cheaper over conventional HR, that's what the code says. They are shop fabricated, controlled quality as compared to conventional site arc welding. 30 to 40% savings in time, which I think I have been talking about. And it, of course, provides larger base spacing. There will be less number of footings compared to conventional resulting. Now, let me tell you that when we go to the RCC buildings as well, those who are doing residential, I think there was a guy who was here with the residential buildings. We are talking about 3 meters by 6 meter spanning. Here we are talking about 50 meter plus. So we have to avoid columns. And people say it's going to be heavier, it's going to be ज़्यादा लगेगा steel. Span बढ़ेगा तो ज़्यादा लगेगा. It's not like that. We reduce number of columns. It's like a concrete building from 3 meter sorry, structural engineers, I have to salute them. 3 meters by 6 meter, it moves to, let's say, 10 meter by 18 meters also now, with the post-tension slabs or a flat slabs or whatever. But in that case, the comment is they are going to be expensive. And I show them an analysis, because I tell them that look how many columns we have saved, how much concrete we have saved, how many footings we have saved, how many plinth beams we have saved. If you calculate an overall picture, you will find that this technology is cheaper. And so technology always comes with a rider of cost saving. Either it is saving costs or it is saving time. Both are equally important because time again is a cost. So you save time, you can go into production earlier. If it is a shopping mall, they will start selling shirts and jackets much earlier and make money. Now there are a few tips which we wanted to give. Frame members are designed in accordance with whatever IS number. I think it is revised also and updated also now, but the basic was that. Double side welding to be considered for primaries. Connection and base plates are designed for actual moments and forces. Nut bolt should be whatever coated. All sheeting screw should have cap of sheeting color. Now many times I find that there is a difference between PV agency A and PV agency B. They try to have some shortcuts. So they will say, "ठीक है यार, nut को color क्यों लगाना है?" I mean that is not there. But there are some companies like Interaj, and I've seen many good companies who actually bring in the caps which match with the RAL color of the sheet, and then it makes really beautiful. Okay. Because we don't want to exhibit the nuts and the joints and the junctions of the steel. We want to hide them actually. So we do that. All sheeting screws should have the caps and all primary members should be sandblasted. Downtake should be metal and from outside of the building. No, I have a correction here. The correction is, most of the time the PEB agencies, they, along whatever the grid they have, they take a gutter there at the top and a downtake from the outside. Now this is actually killing our architecture. Because whatever the length is, it is divided by those pipes running down. And if it is a ordinary PEB agency, the pipe color will not match with the sheeting color. Now that means it is still making the building. And we have come out with this technology basically to make beautiful buildings. Earlier we were calling them shade. I hate that word called SHED. Why shade? I mean, it is a building. It's a built form and it can be designed beautifully. It can be designed beautifully. The length, the junctions, everything can be thought of. We can play with the colors of the sheets. We can play with the planes of the sheeting. There is also another problem. I don't know why, but most of the people, they go with the RCC work or the brick work or the civil construction. No, this is another. Let's give him a big hand, a company called Kirby, who are pioneers in bringing pre-engineered technology. So what they do is they have the brick work, then they have the windows, because the factory inspector says everything has to be up to 3 meters. So they have the windows, 2 meter window, 1 meter brickwork, and then they are caught up with where to put the sheet. So they provide a lintel beam and a chhaja. That means you are gone with 20 days. A lintel beam and chhaja will definitely have 21 days. What we have done is we go for C channels and the sheeting line is 500 millimeters away from the steel line. So I get a chhaja type thing, continuous. It is on the double C channels and we have a soffit panel. Of course, good companies. Some companies will not provide the soffit panel. So once we provide the soffit panel, we already have a line and then I can have my architecture. Nobody will tell me, why those. So I avoid chhaja, I don't require a RCC contractor after plinth. Frankly telling you, because that is what we are here for. We want to use steel. So keep the detailing done in steel. That is very important. I was talking about the downtakes. we don't advise the downtakes from outside. We take them straight from inside of the production so that they can be in UPVC or whatever material you want. You have a nice chamber, you have an outlet designed at the plinth level. So externally I get a very plain surface. Now this is something point to be noted. Pardon? Yeah, we'll come to that symphonic also. There are some, my son Pratik will add on to that. I always say I am Deshi. I was graduated in JJ Bombay. He graduated in Manchester, UK. So thoda farak hota hai. So live load on mezzanine floor, safety nets, load of sprinklers to be considered. Bracing will not be allowed on locations of doors. No, this is another thing. When we started, I think, with these kind of buildings on PB, we went on with the bars for the bracing. Now, why bars? I mean, when we are talking about sections made out of plates, can we not have a nice portal for a door? Can we not take care of the stability of the rolling shutter by providing a frame, nicely designed in steel? So we need to think about all this and avoid this because these bracings are going to be a hindrance for the production, for the movement from one section to the other section. So they say, yaar, ye kya bana diya? You know? So that is one more problem with the bracings, which you need to go for the portal frames. Can be lighter. Load of services to be considered of each column. Now, believe me, I think we had a problem of having multi-storied steel building in industry with loading varying from 3 metric tons to 7 metric tons. I am sure it was not possible for concrete. It would not have been. The way we have, and the way Interraj people have done. Kya ho gaya bhai? I'm going to take you through that project as well. Now, this is something called design data which we must consider for any PEB building. Column out to out, column center to center. What is going to be the tie level? Spacing at every grid, the slope of the roof. Now, when we come to standing seam, we are now coming down to 3 degrees. Earlier, it was 6 degrees onwards, upwards. So we have come down with that slope. So the triangles are reduced. It is automatically becoming flatter and flatter. For those who want to make architecturally vibrant buildings, this is an invitation. Type of bracing on roof and wall, roof panel sheet with insulation and its density. I think I was discussing with these insulation guys yesterday, I think Corning and all these guys. Insulation is very important as far as our kind of country conditions are concerned. So we are in a tropical region where the ambient temperatures are very high and the required desired temperature within the factory building or within the occupational space should be minimum, brought to minimum. So can we have an underdeck? Either we have an underdeck insulation or we can have a pre-sandwich panel on the rooftop. That will reduce your temperature coming down. I'm talking about pharmaceutical industries, certain industries which require anyway, the entire production area needs air conditioning. And we want to reduce the load on air conditioning by creating a natural ambient temperature below, reduction in the temperature. So that can be with the sandwich panel or with the insulation that you provide. Okay, so we can provide glass wool or rock wool, whatever it is, with whatever density, and then we will reduce the temperature at least by 3 to 6 degrees. So this is what is invited. Sidewall gird, end wall girds and projections from column face, which I think I explained to you. Wall panel and its distance from column face also I explained to you. Because, I was trying to tell you that if you have the column and then you have the brickwork, the columns are exposed. How to treat that is a question. So when you have the roof line which is coming out and the wall coming in, automatically these are sorted out. So our wall is free of the column. The footings and the stub columns are designed in such a way that you have a bracket and you have a wall interruption of the columns. and it also saves my time as far as my brickwork up to window sill is concerned. I can run it, and the fabricator, I mean the PB primaries can be raised from inside without wasting time. Accessories include gutters, curved eaves, downspouts, soffit panels, and of course the fascias. Now, I believe that the fascia is a gift from the PEB agency. And we can really treat the fascia and make the building as beautiful as possible. And the fascia load is transferred if you are pre-planned everything. And so the triangles are out. You can have a very simple rectangular building. Or if you want to play with the shapes and shapes, you can do that with your fascias. So think about the fascia in serious. We also have daylight panel in polycarbonates, framed openings, canopy with soffit panel. There are many companies who want to cut corners. They will say soffit is not required for a canopy. So you will see the entire ugly kitchen work when you have a canopy and you have the framing seen from bottom. Why? I mean, what is the great saving that you are doing? So you can have a nice soffit panel. So, canopy looks as beautiful as probably Katharina Kaif. Okay. So, paint finish, ventilators, diameters and numbers, column brackets for services support. Now, this is one point which actually normally missed out. The various kinds of services that we have in a type of industry that we are dealing with, we have various kinds of gases, we have various kinds of liquids, we are firefighting thing coming up. All these things have to be pre-thought, pre-decided, and their weight per running meter. If it is known, we can design the bracket supports either, or we can actually come out with some different kind of support system. Fascia I talked of, EOT considered and its weight, monkey ladder for roof and EOT beam and its location. Now this is, generally how we invite the PE offers. And many times people really don't get into all these details the way we do. So what we do is we will just specify all these things that you see on the left side. The length, width, tie level, column spacing. If there is a junction like that, the wind bracing, what kind of wind bracing you are allowing, type of bracings if you want to provide on the wall surface, type of bracing you want to provide on the roof, because then it is supposed to be taking care of the wind pressures. And this is, as I told you, this is that multi-storied building which we did. Roof panel, roof insulation, various accessories in terms of, you can see that on that side. Cutouts and sinking in the slabs. Now, when you talk about the multi-storied building, this is another problem. We also require some cutouts or sinking. If you have a toilet block, you require a sinking. So this needs to be detailed by the architects and engineers much before, because otherwise you will end up into an issue. Visited, I have seen that the toilets are actually raised out of the production area to accommodate the piping below. Now this is a criminal mistake done by architects and engineers. So if you can do that, roof lighting, wall lighting, framed openings, canopy, paint finish, kind of ventilators.
Double jam detail, since we have the sheeting outside.
You can take it up after I finish. EOT crane, monkey ladder, as I said, fascia, service brackets, and shop floor loading. Now, this is very important, is the shop floor loading. We have, I think, yeah, he's there. Why don't you join me? No, come. So what we do is, this company called Beckert, which is Belgium. You have to always rise in the morning and salute the Queen. That is what I say. Because all the innovations done in the world are from Europe. And he represents a company called Beckert. We get all our industrial flows designed by them. And we don't provide reinforcement like blindly all our RCC designers are recommending. And people tell me it is because the client wants it. So we have designed a floor which is 7-ton loading, right? 7 ton per square meter loading in fibers. And at a height of 13 meters, 7 meters. So it is possible. Yeah, and thickness is only 175 mm. So possible. So please see to it that you reduce the reinforcement bars, the rebars yesterday we were talking about. They can be replaced by fibers, and all the fiber manufacturing companies are supporting you guys with their design and analysis. So you are ensuring, the question answer will give you time. They are ensuring how the floor is going to behave. We have those things. So we are going to show you how it behaves, you know. So you ensure whatever we have learned in the colleges in terms of engineering, the behavior of concrete and steel, can be graphed, can be shown to people. Now these are the a process flow diagram for a PEB building, how it moves. Point number 1, comparing total steel content against per metric rate quoted by the agencies, very important. Per square meter, what is the tonnage content? A good design will have lesser tonnage content, a bad design will have more tonnage content. More the tonnage content multiplied by the rate, it is going to be costlier. Number 2, compare the erection cost, prefer any agency which has their own erection team. The moment you depend on the local erection team, you are asking for troubles, because then you will have all people coming, including the politicians, coming as erectors. Now, this is something very, very serious that is happening on sites. So, that you engage company which has its own erection team. And I was talking to people from the PB agencies that the erection team needs to be trained for your kind of products and your kind of systems, so that they don't end up making any kind of mistakes or errors. Ask the agency to study project design in terms of plans, elevations, and sections. Now, the marketing team of the PEBs, they are always forcing the design team to do it quickly. And there is a saying in English which says haste is waste and hurry is dangerous. So please see that the best part of the PEB is the design. So try to understand the requirements of the client or the architect or the consultant. Try to have options of designing the whole thing, and then probably give it to the costing or the marketing team to actually evaluate how much is going to be an offered price. Explain the detail desired by the client to or the architect. Selected agency shall give force acting on column. Now this is very important, that they need to actually work out what are the forces that are going to act on the foundations and the columns, and then we design our foundations in the columns. So that is stage, very, very important stage. Agency to submit sets of drawings known as the GAD, the general arrangement drawing. And many times this is also hurried because there is a pressure from the client. अरे यार जल्दी करो, मटेरियल जल्दी भेज दो, प्रोडक्शन चालू हुआ कि नहीं हुआ, many other things that they start happening without getting into a proper detailing. So the general arrangement drawing is very important, must be checked by the concerned structural engineer, must be checked by the architect to correlate with his architectural requirement, approve that, and then it goes for the further detailing of fabrication or the workshop drawings. Agency to submit sets of drawing known as GAD, dispatch anchor bolt and templates, and then of course the agency will dispatch the anchor bolt and the templates. So by that time I should have brought all my foundation columns to that level. If you are really working against time, this particular process, you should have brought your stub columns up to that level where the templates are placed, anchor bolts are placed in, and the columns are cast. We can save about 10 to 20% of the time in this. Dispatch anchor bolt and templates to site, preparation of fabrication drawing by agency. Manufacturing according primary, secondary architect to visit the manufacturing unit before dispatch. Now this is very important because if we are doing it, we always think that we are always right. Somebody else's, the third party checking is required. So the architect or the consultant or the concerned structural engineer must visit the particular unit before it is dispatched. And because of the pressures of the marketing team and what is the other team, I don't know, involved. So, but the procurement team, they actually force these guys to dispatch as quickly as possible because the next bill is waiting for that. And then the dispatches are not made in sequence of erection. So the erection starts happening, but there are major members missing. So the listing of primary members, secondary members, scheduling of that, and dispatch schedules of that are very, very important. And they must be explained. I am sure that the marketing team of any PEB agency and the production team and the dispatch team, there is always a disparity. There is always a gap, a communication gap. Actually, they need to sit together and have a nice training done. You know, how to go about it, save time, checks and counter checks. All those things must be done because otherwise we face a lot of problem at site. Because pre-engineering building, we cannot do anything on site. No, that is very important. I have seen many PEB guys where drilling is done on site, welding is done on site, bracketing is done on site. This is not PEB. And every fabricator today, at least in Pune, they say that I am a PEB guy. He is not. He doesn't know the softwares. He doesn't have all the machines that were shown in the presentation in the morning. So if they don't have all that machines, if they are not working on the software, they are working on StatPro and all that, which is going to give you a more requirement of steel, then you are really not a PEB agency. So please see to it that you follow those things. Supply of ancillary sheeting material. Erection team to move on site and execute preliminary work. Now preliminary work is many times they have to put them, sort them out, paint them, at least the initial painting on site is done. Erection teams will execute the primary and secondary work, finalize the alignment of structure. Now this is another important stage in the entire erection, the alignment of the building. If it is not done properly, it leads to many issues at the end of the day. You know, the alignment, the corners, the squares, whatever it is, has to be done properly. Installation of roofing sheets and cladding sheets as per design. And while you do that, please see to it that you need to do the insulation thing below. So the first is after the purlins and the rafters are placed, the main thing is the insulation laying, ensuring that the insulation is laid properly so that they always look straight and not wavy forms. And then you have the sheeting done. The detail between sheeting and fixing of insulation is also very, very important. Installing corner soffit panels, doors and windows frames, turbo ventilators, polycarbonate glazing panels and undertake roof, etc. is very important. Now, I have seen that with the standing seam technology coming up, these kind of things nobody has really detailed out. Providing, for example, a glazing in the top of the roof with a standing seam, detail not available. Providing the skylight with the standing seam, detail not available. The purpose of standing seam is to have a punctureless roof. And when we want to put all these ancillaries, we are trying to puncture the roof. So we are actually murdering the whole concept, and the leakages happen from these areas. Okay. Earlier we were to screw it, and while we were screwing it, we were using some materials with all our heat procedure. In 3 years, it will give away, and there will be a lot of leakages coming into it. And the clients will tell, "Kya yaar roof banaya, usme se pani aa raha." And the pani never stops. Okay. So even if you want to do the campering treatment, all that, it cannot be done in wet conditions, you know. And after 3-4 years again, because of the heat, it becomes stiff, it gives crack. And the moment it cracks, the water falls down. So these are certain points which need to be done. Finishing touches are therefore important before handing over. 16 points I have taken you through, which is the procedure to be, which is the procedure to be followed. Quickly running through the same 1, 2, 3, 4, 5. The next one was 9 to 16. So if you remember all that, I'm sure you will be able to, you actually have to think about this because these are just pointers. You have to think about this, work over this, emphasize on emphasize on the right procedures to be followed. Visiting the plant before dispatch, as I told you, very important. GAD checking and approval, very important. Normally, the general arrangement drawings are to be signed by the structural engineers of the architect or the consultant. They give some comments. These comments are not read and followed by the PEB agency, and you still continue having all those deficiencies in your design. This is what I am experiencing. You took this photograph also? Okay. So this is the building I was talking about, the multiple levels done by Interarch now and very nicely designed, no doubt about it. We have a gantry, we have a 13-meter truss style level, we have all those 3, 4 floors, all are heavily designed, heavily loaded conditions. This is again the sheeting and the polycarbonate and everything. The insulation, this is the brickwork I was telling you, free of columns. Can you see the brickwork running through and the columns are inside? So there is no issue what should be the junction between the column and the brickwork. So it runs through. Beautiful canopy coming out. Yeah, then I was supposed to also take you through solar roof. They are saying you don't have to put the solar panels on the roof. They say solar panel itself will act as a roof. You want to explain? Okay. Okay. So this is a CO2 emission thing. As you know, solar panel is going to be the language tomorrow. And so it is better to understand this. Maybe the people who are just started in India. So we can always give them a feedback that we have when we use in terms of its load, in terms of erection, in terms of junctions. Probably that's again a vulnerable area, panel to panel junction. You can see it on the top. So those white lines are likely to be vulnerable again in tropical countries. But then these are some of the plus points that we have in terms of CO2 emission, savings of carbon, better aesthetics, of course. Their circulation, and you can see the man walking over the roof as well. So you start with the design, roll forming of the stat analysis, the roll forming, then it goes to re-strengthening of the existing structures at times if it is required, the in-roof installation and commissioning of the in-roof. Now in-roof is one of the solar panel kind of company. So this is that multi-storied building in Mumbai which is known as Indus, which is a Kawasaki vendor, I would say. So it's a Japanese thing, and because of steel I could get a pergola at that height. Otherwise it was not possible. And the pergola has given me a very aesthetical look. All these floors are actually, and you can see the production area behind. That is the plot area and the built-up area. The kind of plan that we prepared. These are the sections. You can see all the floors overlooking the production. Great advantage to the project in venturing for larger cantilevers, pergola, detailing of external facade of the skin. These are some of the more detailed things.
You can mention it's a hybrid structure because all the RCC staircases are.
Yeah. So there was a fire regulation saying that staircases cannot be done in steel. So we had to actually integrate concrete. I think the lift shaft is also in concrete, and the rest of it is all resolved. And we have invisible fire curtains. They are not seen. Whenever there is fire, the curtains will come down. So we use some technologies. And now, of course, the steel is going to be fireproof also coming up. So if that comes up, I'm going to the chief fire officer of state, so that he will not trouble us anymore, because we want a complete building in steel. So the crane and all those things, a very compact site, of course. As I said, the detailing needs to be done. Then I'll take you to the next technology, that is LGFS, or the lightweight and speedy construction thing. So we had this great challenge that there was a factory existing and it did not want any dust inside. So we cannot think, but they wanted a ground floor and a first floor building within the factory building. So we thought, what could be the technology to be employed? Wherein they were not allowing me to excavate the ground, so no footings. All engineering guys must listen. No footings, no plain beams, nothing. We just drill holes in the concrete. We have chemical fasteners and we raise with the light gauge steel. And I'm showing you day wise. I'll show you how many days it took me. No, this is just the expansion that we did. Yeah. So this was the plan on the first floor. We had a canteen below and we had an office below, office on the first floor within the factory. Day one excavation, slightly, only drilling in the floor, not really making kata. You just drill. Okay. Day two, anchor bolt fixing. Stage 3, erection of the PB. Done by Interarch again, so thank you. And award-winning project. Fourth one is assembling of members, form frames, LGS after receipt of material. Assembling a PB staircase on site. Each number that I am giving is 3 days. So the project was completed practically in 21 days, 30 days. 30 days. 30 days handing over the entire canteen building. The entire labor is so happy. खाना मिलता है अभी वही अंदर ही, बाहर कहीं जाने की जरूरत नहीं. And of course the office space overlooking the production. So you can see now it is getting completed. Fixing of framework, internal walls, the fire running through, ceiling installations done. So we had a false ceiling because it was the office area on the top. We did not have it all the times. And then external cladding of fiber cement. So we normally don't use brick. ये brick में अभी ऐसा है कि brick is not available only. People talk about the stones. No labor can lift the stone the way they were doing it earlier. They cannot lay the stone the way we have learned in colleges. So why go for brick and stone? So we have dry walls. So a lot of different walls are coming up and we can experiment with this, save time, safety, fire safety and everything. So all those properties are there and we completed that. This is not the plastered one, it is a ready-made sheet that is just fixed to that grid. And then, of course, the interiors. So the Italians are happy. They say you could do it without, the production was on while we were doing this, and no dust and nothing. Okay, friends, it's time to welcome this new technology, probably refine them to suit our design as cost parameters, working conditions. But then we all will probably succeed in catching up with the world in construction and yet achieve our own Indian flavor. This is my statement. And I'm sure we all have to work over this. Because in every dish that we serve, we have Indian touch. So every building that we raise, we should have Indian touch. Don't follow the technology the way they offer to us because they need to be redesigned to suit the Indian climates, to suit our mentality of the construction guys. And I'm sure for every single thing that we have on construction site, the solution is available. People are scared to start with these. Recently here, we could complete the entire workers' toilet block with a huge building itself in steel with dry walls, aerocon panels, and that's it. We have done it, and there is a tremendous saving of time as well as the cost. So it's possible. Initially, they had a resistance to our idea, but we completed that. So then and then only we will be worthy to say that we belong to the strongest economy in the world. It is steel alone which will make it happen. And that is why the title of the topic was Steel All the Way. So now I think that's it from my side. We will take up few questions. And if you have any queries, we will take up that. Okay, some of the, the projects that I showed you, they have already won awards. We almost get an award every year, every single year. So that is it from me. We are now designing around 15 railway stations across Maharashtra state, 4 in Nagpur, and they are not metros. They are regular stations to be facelifted with modern features. They want something like airport structures. The program is called Gati Shakti, declared by the Prime Minister of India. We are doing that. And we are also engaged in a couple of airports, which we are doing in Madhya Pradesh. And we want to actually employ the new technology as far as the steel is concerned. And I'm sure it's only steel and other new materials that are there. Like I think airport authority also was saying that you must lay the steel below the concrete. And these guys from Belgium, they say it is not required, we'll do it in fibers. So, so all these things need to be thought over, and we need to convince our own engineering guys who are very senior. You have been lucky enough to listen to me today because there was not enough introduction given. But many years ago, I designed a course called Architectural Awareness for Railway Engineers. And I got a Rashtrapati Award for that, so it's about 25 to 30 years old. There is an institute called Indian Railway Institute of Civil Engineers, and I used to conduct these kind of 2 day sessions to educate the engineers of railways. And thanks to that course, that most of the railway officers today, the bosses, they're all my trainees. So, okay, so it was a good day interacting with you. You have some questions. My son will take up those questions because he is more into steel technology. Please join Pratik. Pratik has done his graduation from Manchester, UK. I am a gold medalist from JJ Bombay.
Hello. Yeah, any questions? We can take the questions now.
You had some query, no, right?
But the slope for the solar roofing is the same that we take for any roofing. So they can work with about 4 degrees of slope. So they have no problems with that. Because the surface area is basically your solar panel, the friction rate is very low. That is why the water flow ratio is quite high. The links between the panels have been sealed with a rubber gasket below and a silicon joint on top of that, and then they have a T plate which kind of seals that particular joint.
But those details can be improved because I think that is just the beginning in our country. So we can improve the junction details. It is vulnerable that way. I feel so. We are experimenting on these structures. So let's see what are the results going to be.
On the drainage end, I think they need to work on the details a little bit, but we are on the way to work with them and develop some new details on that particular part.
I think I will ask him to, elaborate on the downtake issue which we had. We are now working on a siphonage system. You,
Yeah, so the Gabriel came out with this technology almost 8 to 10 years back, which is called a siphonic drain. So you have this helps you reduce the size of the drain pipes, and also individually, if you look at all the buildings that you have right now, they have these drains which are coming down at each column, and then you have them coming on the outer face of the building. Now, these guys give you a warranty that there will be no leakages, since they have a two pipe system. One is your basic drainage system, and they have a ancillary emergency system as well, which comes into place. And then you can actually bring it down. So the maximum range is about 55 meters. So every 55 meters, you can have only two pipes coming down and coming out of the building. So which is a beautiful technology. Also, if you can even bring it further. I mean, we have designed it in one of the buildings right now at 120 meters, where only two pipes are coming down. So we have increased the size of the piping, but that is how you can do it. And again, the flow rate and the way the siphonic system works is normally your water level is only half of the pipe area. So the siphonic pipe actually gives you complete volume of the pipe. So it kind of sucks the water out of the drainage system. Yes, sir.
Hello. So IS 800 2007, in that there is section 12 where we use the capacity based design. So in seismic we use capacity based design, but we apply only the actual forces for our structures. So following capacity based design is the basic principle in seismic.
Yeah, see that these are certain factors that we are saying architects should look at. When it comes to structural design and the stability of the design, there are other factors that also need to be considered, which is it has to also, in certain cases, it has to also connect with the IS code as well. Otherwise, you do not get the structural stability as such. So that has to be taken into considerations. These are only the points that we have mentioned are purely for architects and the project team that they should look at. These are just the basic ones. There are, of course, there are additional terms that have to be taken into consideration as well.
no, Amit Bhai can also highlight. Yes, Amit ji.
See, what you said is right. Design has to, as per Indian standard, they need to have design as per capacity based. Your connection have to be 20% more of the capacity. I had opportunity to discuss with some of the professors and some of the practicing consultant also who are writing those Indian standards, and they have rightly said, they said no, that is because when Indian standards are published, they have certain research papers based on which the Indian standard is upgraded. Later on, based on actual experience in field, they realize that calculating capacity of that joint is really not possible, depending upon, I mean, whether in bending moment, whether in axial forces, in shear forces. So combined capacity is what matters, and calculating combined capacity is extremely complex equation. So rather than going for capacity, if you are providing 20% extra of actual loads, that also will suffice requirements of ductility or suspect requirements. Number one. Number two, there is a new code which has come in practice now, 18618. which you can go through. They have upgraded those some of those provisions. They are already made available. So you will be. And third point, wherever, I mean, at least in my practice, I feel when provisions are not available in Indian standard, we can refer to some authentic international standard and latest version of those standards. You can refer to that and get feedback. AISC do not ask for that capacity based, never. So these are the reasons why Indian Standard Committee also feels that no, it should not be capacity based. As long as you are providing 20% extra of what is required, it's good enough. Yeah. I hope I'm answering that right.
So actually, when this code came, we were the first to apply, and we had suffered in that particular case. So we had also approached IIT people. So they said we can do it. We did it, and it was a quite bit a problem. So now we are not following it, but it's still there.
It's in the mind.
Code that it should be there. So always there happens in specifying that should we follow this or should we follow that. So second question. Yeah. Yes, yes. So second question was related to them, that floor. It is a steel fiber that you are suggesting. Now steel fiber is also corrosive in nature.
Correct.
So what is the life we should expect, because it is very small fiber?
See, steel fiber, there are three ways to look after that. First is initiation, propagation, and the impact of that, effect of the corrosions. Okay. So initiation, if we say it is delayed because once the fiber is inside the concrete, the surface area of that is 3 times more than your normal rebar. Okay. So initiation of corrosion is delayed. So then your propagation. The propagation is like if you have a laminar reinforcement, the propagation is laminar throughout the section. Then you can see that the concrete is getting separated, and the concrete and the rebars generally corrode and they expand around 8 times more than the initial dia. But here the steel fibers, the diameter is around 0.75. So it will never expand that much. So the effect is also on the concrete is delayed, and it doesn't affect in the cracking of your concrete. So it has better aggregate interlocking. It is well embedded inside the concrete.
See, my question is related to when it is a wet mix. In the wet condition, when we are making that particular thing, concrete is wet.
Yeah.
In that case, there will be some initiation.
It will never happen condition, because the cement paste is completely the coating is done on the fibers. Okay, so we are mixing it in the direct RMC. We are not dry mixing it. Okay, we are mixing it in the RMC plant, and it has never happened like the corrosion has happened, and it is not continuous reinforcement. It's a discontinuous reinforcement. So even if your fiber is propagating outside half the way of the fiber, it will die its own life. So it is not propagating throughout the concrete section. So corrosion also, it is delayed corrosion and better aggregate interlocking. It doesn't allows the water to seep inside the concrete. That's what I meant by better aggregate interlocking. So design life is same as what we are dealing with the normal 25 years, 50 years, but it is better than your normal concrete that we do. Because see, in the normal concreting, if a crack has started propagating, there is nothing to resist. Okay. But in the fibers, if you add fibers to your normal concrete, the fiber is present from top to bottom of your concrete, and it is not allowing the cracks to easily propagate from top to bottom.
I understand after process, but during the process, I just had the query that during the wet mix.
In the wet mix,
Probably his question is rate of corrosion, right? Once the corrosion sets, if at all, once the corrosion sets, your fiber will be 0.75, 1 millimeter max. So it takes much lesser time to corrode away.
Correct.
Compared to the main reinforcement, which is 10 or 12 millimeter.
Correct.
Okay, so that reinforcement corrosion will take some time. Now, I'll give you example of some of the RCC structures built in Mumbai.
Correct.
Maybe Vashi Bridge or something like that. Okay, which has stood for 20-25 years. But after 25 years, the reinforcement is completely corroded. It was epoxy coated. Mind well, it was epoxy coated.
Okay.
Still, it is corroded away. It happens because of atmospheric.
Correct.
Now, if those 16 or 20 dia bars can corrode away, the kind of fiber which you use will take no time to corrode away. So, I mean, in my opinion, as a structural consultant, you are not replacing structural steel. You are not replacing the main bars. You are only creating an additional strength in a concrete strength by
We are
providing
adding your
those.
flexural capacity in your concrete, actually.
Yes, you are adding to that. You are not replacing that main reinforcement in any case. That's my point of view. You can have your.
But we are doing it in the grade slab applications. Okay, so
Yes.
while adding the steel fibers to the concrete, what happens? I will tell you. The cement paste gets coated on the top surface of your fibers. So the cement paste itself is not allowing the the fibers to corrode. So what we are adding it's again not allowing the fibers to corrode while mixing in the concrete. Okay, so hope this the answers your question. Partly, I feel so.
Till it's proven.
It is proven.
Yeah.
See, we have structures which we have seen that has not effect of corrosions on the floor, and the floors are sustained well beyond their design life. Okay, so currently the system itself is like 40, 50 years old. In Europe, we are dealing it from like past 20 years, and in India, it's from past 25 years that we are doing structures. From 2007, we have started our own production in India, but obviously, before that, we were dealing in India. So the structures are still sustaining. So it's proved that nothing is happening. That the corrosion is not affecting while mixing in the concrete.
Just for proof, the building that Dad showed you, where we did the LGFS, is being done by them, and that building itself is almost 17 years old, and no crack on the floor.
No, one basic question to engineers: flooring is a tension member or a compression member? Any floor, this floor, any floor.
You take any member in the world, not only this slab or that beam, they will have both tensile forces as well as compressive forces. Nothing can have only tensile or only compressive. All right. So if you talk about a slab which is simply supported, will have tension at bottom, compression at top. Right? That's why RCC, the main fundamental of RCC says the steel takes care of tension, concrete takes care of compression.
No, that is
Absolute basic
agreed, but a floor like this, which has a base of stone below,
Yes.
compacted stone below and compacted earth below, and we are also putting a PCC layer. On the top of that, we are putting concrete layer. Is that concrete surface acting as compression member or tension member?
Compression.
So why do you provide steel? That is my question.
So normal recommendation, if you see, would be to provide steel reinforcement at center, which is neutral axis.
Yeah.
Is not the steel is provided to reduce temperature cracks, to take care of local stresses.
You're talking about shear failure, right?
They're not shear, bending failure only. If you in locally, suppose some of your stones below or
No,
rubbles
you
settle.
ensure proper ramming and
Never happens. It never happens.
proctor
at site.
density to 90 plus.
It never happens at site. So to take care of those settlements, local settlements, you need to have some reinforcement. Number one. Number two, to take care of temperature stresses, you need those reinforcements. Number three, those reinforcements are never provided at bottom or at top. Till 150 mm thickness, they have to be provided at center of the slab, neither at top nor at bottom. Right? Center means it is at neutral axis. You are providing it.
Few years ago, Amitji, I asked this question to all my structural engineers in Pune. Where we should provide the reinforcement? Top, bottom, or both, or center? And you have given the right answer. Let's give a big hand to him.
Thank you.
And we will provide the reinforcement at the center of the concrete
Till
floor.
150 mm thick.
Yeah,
If it is thicker, if you have 200 mm, you will need double jali. One at bottom, one at top.
But that is because of 20% safety something?
No. Concrete don't work at 20% safety. It is 2.5 times. But please accept it because concrete is non-homogeneous material. There is no guarantee that concrete at every point will give you same behavior.
Correct.
right? So you
So
have
let's
to
give a
provide
big hand to
those.
Bhushan from Godrej. You're from Godrej, right?
Yes.
So he also gave a very beautiful opening to certain issues relating to particularly to steel and concrete hybrid kind of construction. So very good. Anything else left over? Any other questions? Quick? Yeah. And thank you for joining this session so that it was a big support.
Thank you, Deshmukh sir, for your wonderful presentation. Myself, Nawaz, I'm from Intrak. Basically, I wanted to comment on one thing. First thing is, in your list of 16 points, the first point was compare weight and price. I believe that's an intent to commoditize. I mean, that's what is happening in the industry. Basically, people tend to commoditize this when this is more than just weight and price. So, I mean, with the sort of projects you have done, you do understand this primarily doesn't relate to just weight and price eventually. That's the reason all this,
I will give you answer to this. My observation is good companies who have very good design team inside, they save on design and their per ton cost is more. Ultimately, the multiplication factor may come down to a very reasonable price. I am not against it. Other companies cannot design the way you guys are designing, so their content of steel is more, but their price over the steel per ton is less. But of course, you people are charging because you have better overheads, and of course, you want to cover up your design team expenditure as well. We do understand. But this multiplication factor is the main factor for consideration on PB agency finalization of discussion. As far as clients are concerned, we understand your pains, but the clients are concerned, these are the points to be discussed because it's very difficult to actually segregate and explain.
Now, this is what I was arriving at. What I want to say is that rather than looking at the price and the quantity, you should look at the overall cost within the prescribed scope. Now, that's my point. Now, going to the other one, you talked about the time frame. One thing to the fraternity which I want to talk about here is I've been into hundreds of discussions where at negotiation there are serious discussions about timelines. Talk about, we fight for weeks, a week and even days. Like can you postpone it by 2 weeks? But then the biggest problem that I've seen is in this rush to finish the projects, the initial work that is required in terms of planning, where the architect and the consultants come together and freeze the building parameters doesn't happen. Once that doesn't happen,
we agree to that. We agree to that.
That's where one thing you should look at. So I probably missed that one of the presentation. So I think otherwise, I really owe to you a beautiful presentation, lots of information. Thank you.
I'll just pass on to sir.
Good
Yes,
afternoon,
Amisha.
boss.
Good afternoon.
Yeah.
How are you?
Good afternoon. Good. Very common question which I have asked to all my customers, or rather they have asked me, and then I had opportunity to discuss with them. What do you expect from a consultant or from a PEB agency? Your wish list, number 1, number 2, number 3. Okay. All 1, 2, 3 is saving in time. That's it. Okay. Because for them, every day saved is money.
Absolutely.
It's turning into money for them. So how do we reduce those time frame? Okay. Once we get into that step, probably many of the suggestions which you gave will come into picture, that you will have to work like this.
Yeah.
Do it this way, you have the answer to your own questions.
It's a system. We need to understand
Exactly.
predominantly, when you call pre-engineered building, it's a system by itself. The entire thing runs on a particular way, the value chain goes around. Now, if you try to shortcut one area, thinking it doesn't happen. That's what you also have seen, we have seen that.
Correct.
The
If
process-
don't break that.
Yeah.
Don't break that flow. If the moment you break that flow, you have it.
It disrupts it. Short
have
term,
it.
you might feel that, but it
Somewhere
doesn't
you will
happen.
get trapped.
Absolutely, yeah. Thank you.
Yeah, thanks.
He said with experience you can do it efficiently. We did 45,000 square feet building in 45 days from pencil to production in Chakan. That's why your presentation. Chalo, thank you.